is looking for a shuttle sort algorithm. So what we're going to do is we'll take the names. So we've got R for Rob, Eve, Meg, Ian, and Xavi. Okay, so what does shuttle sort get us to do? It gets us to do our shuttle. So our first one here. Now, it doesn't ask me to count comparisons and swaps, so there's no need to. So at the end of the first pass, R is compared with E and R are swapped. Then the next pass, we're comparing these three. So we compare R and M, and we will swap them. And then we compare E and M and don't swap. So it's E, M, R, I, X. Then we're doing 4. So R and I get compared and swapped. M and I get compared and swapped. E and I get compared and do not swap. So then we've got M, R, and X. Now, there is a final pass here, and if you don't draw this one in, you will lose a mark. So you've then got the entire thing. R and X get compared and not swapped. Okay, so you must write out this final line again, because this final line is showing that you are comparing these two, but you're not swapping them. So that's a really, really quick shuttle sort. We're not being asked to count comparisons and swaps. We're not being asked to do anything like that. So it's quite straightforward, and also we've seen the examiner's little joke there that they want to remix the shuttle sort. So part B then is looking at our understanding on sorting algorithms. So we're told that a list of 10 numbers is sorted into ascending order using a shuttle sort. How many passes are needed? So we can see that, well, 5 numbers in this question here required 1, 2, 3, 4 passes, yeah, with the final pass being here. So it is one less pass than the number of numbers. So it is going to be, for part 1, it's going to require 9 passes through the algorithm. Okay, the other way of looking at that is thinking, well, you've got your 10 numbers, the first 2 get compared. So if we've got our 10 numbers 1 to 10, for example, I'll just take a bit more space. The first pass, second, third, 4th, 5th, 6th is up to the 7, 8 is up to, 6th was up to the 7, 7 up to the 8, 8th pass, 9th pass. Okay, so you can work it out as well. The second part, give the maximum number of comparisons needed in the 6th pass. So in the 6th pass, that is when 7 items are being compared. Okay, so it was 1 more because the first pass compared 2 and so on. So what I'm going to do here, I'm just going to quickly write out my 7 items. I don't really care what they are. This time I'm going to go for letters. So what we're going to be doing is comparing, and we want the maximum number. So we've got to imagine we're comparing and swapping, 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 comparing and swapping or not, it doesn't matter. So 1, 2, 3, 4, 5, 6 things, 6 comparisons is the maximum number from a 7 item list. So 6 comparisons, and potentially up to 6 swaps. Given that the list is initially in descending order, find the total number of swaps needed. Okay, so for part 3, the list is in descending order. So we've got to imagine it's going something like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So on the first pass, 1 swap. So the 8 and the 9 will be sorted. On the second pass, it's going to be 2 swaps. Then on the third pass, 3, 4, 5, 6, 7, 8, and 9. So 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Obviously, you've got a calculator, so you could just plug this in, or you could notice that you've actually got your number bonds to 10. So 1 and 9 is 10, 2 and 8 is 10, 3 and 7 is 10, 4 and 6 are 10, so that's 40, plus the 5, so it's 45 swaps is the number that would be needed if we were working on a list that was completely in the wrong order. Okay, so after the first pass, we'd do 1 swap, second pass 2 swaps, and so on and so forth.